Thanks, Jim. Then, hey everyone, my name is Alex. I lead DevOps and Cloud Center of Competence at DataArt, and my primary role is to drive the technology expertise, identify trends, and help customers with doing the right things in cloud, as well as establishing partnerships with areas like chaos engineering. So the topic for today's discussion is the chaos engineering. And this is really this is not a new term in the industry. It has been there for a while. And right now, it seems to me that it's almost a buzzword. I like to talk about chaos engineering in terms of the either reliability or resiliency assurance. It seems to me like a more suitable term rather than like being in chaos. The reason why this particular thing appeared is because downtimes are costly. And Netflix found out this expertise, this area quite a while ago, and they came up with a concept. And the chaos engineering means that instead of anticipating when downtime happens, you actually simulate it. And by simulating it, you prepare for it. And you prepare not only for downtime, but other types of events that might occur, especially in the cloud environment. We're talking not only about things like someone pulled out a cable in the data center and shut down the whole floor. We're also talking about things like upgrades of the database and that happened during the maintenance window. So such events occur all the time. And typically, the cost of downtime based on information from Gartner, it's like $336,000 per hour for the average company they interviewed, which of course is an average. It doesn't mean like it costs this much for everyone, but it's a range. It's like for someone it's 100K, for someone it's 800K. So typically companies find out about this the hard way, and downtime and outages, they happen regularly. As I said, for example, last year, around last year, AWS, for example, experienced 2 availability zone level outages. Google, on the other hand, also has the list of incidents, and typically it's a network-related incidents that happen for majority of their services, and things like that, they happen, and they typically affect everyone, and not everyone is prepared. But in addition to that, chaos engineering is not something that you will rush into, right? Because it's an unknown territory. How would you simulate the error? What do you need to account for, and things like that. And so there is a blueprint on how you would do this. We like to think about this from this crawl, walk, run, and innovate mentality, but in the end of the day, it's about being able to identify what does it mean for your product to actually work, which is, in the chaos engineering terms, it's a definition of the steady state. This triggers the need for observability being in place. So you should see all your logs, you should see the metrics, you should be able to get the view of the application and see when everything is all right and when things are not good. And when you do this, when you have all these things in place, you come up with a hypothesis. Hypothesis should challenge the steady state. So we're talking about my application should function, and define what should function mean if I lose availability zone, for example. And that's kind of how I'd like think about it. Typically, with the chaos engineering integration practices, you'll see that you should start small and do like surface level experiments, and like let me add a CPU, let me like add 3 more gigs to my RAM and like see what happens. Let me kind of kill the networking and see what happens for a certain surveys. But it's not something that happens in the real life that often, right? Typically, if something happens for one surveys, especially if we're talking about the microservices world, the same thing probably happens for some other services. And that's where the experiments such as failing of the availability zone they become very handy, because you have enough blast radius to not destroy the whole application, and still you affect a lot of resources, affect a lot of components that will allow you to see like whether the app can withstand the disaster. So when you do when you have this steady state is defined, you have the monitoring in place, you come up with a hypothesis, it's it has to be somehow implemented. And there are several ways to do this. We're going to explore 2 today. Ideally, like you would start with playing with this whole thing in your manual environment, and it would take some time to develop these things, and then you would execute this in the development environment to see how whether it can withstand whatever it is that's coming for it. And after you challenge the steady state, you typically get the bunch of errors out of the as the result of the experiment, and you have a backlog to fix. So chaos engineering is like a test, right? It's not something to the bunch of errors, you go and fix them, then you need to run it on some cadence to be sure that these things never happen again, or if something new appears, you know about it proactively. So that's where the automation comes from, and the need to integrate this into the SDLC. So chaos engineering is not a one-time exercise. It shouldn't be it shouldn't be in the end of the day. It can be for your very first experiment. However, when you want to integrate this at scale in your organization, it's something that must be automated. And again, running this in the development environment is one thing, but development environment is not production. Ideal goal is to get it running up to, including the production environment. So it's not going to happen overnight. Application has to be reliable enough to fail, let's say, availability zone in production environment, and be sure that everything is going to be all right. Because in the end of the day, unless you run it in production, you're never going to be sure, right? So you can replicate these things in the lower environments as much as possible, but production is production for a reason. So just to reiterate, we have the definition of the steady state as the very first step. Then, in order to define the steady state, we should be able to have observability in place. Then, after that, we come up with a hypothesis to challenge the steady state. And we implement the hypothesis, the experiment, run it, and make it continuous. So, and we're not talking about like a single experiment, right? You can start with one, but availability zone outage is not the only thing that happens. Let's say like databases can restart due to the upgrade during the maintenance window. APIs can become unavailable. APIs, let's say data store in GCP can become unavailable. So such experiments, like they will only grow, and the number of the experiments that you're going to run, it will increase. So when you have the enough volume of the experiments, you can actually like randomize them, for example, and be sure that your team is actually prepared for a potential disaster. So let's talk about the tools a bit. There, like, obviously, everything can be done with Bash and Python or Terraform, and we're going to talk about it. It's actually one of our experiments today. There is a bunch of open source tools such as Chaos Mesh, Litmus Chaos. These are, in particular, they rely more on Kubernetes rather than on a cloud environment specifically. And then there are platforms such as Harness, which is an enterprise version of Litmus, and they allow you to do more things, and they allow you to integrate it into these DLC better and things like that. And like another example is Gremlin. They are a chaos engineering platform too. So again, you can think about chaos engineering as a form of testing. However, it's not a QA, right? It's like the purpose of chaos engineering is not to verify quality of the product. It's rather to gain confidence and be aware of the steady state of your system. So we do not verify how the system works in this case, right? So we do not run like end-to-end automated tests, and we do not perform regressions and things like that. We verify that it just works. So it sort of overlaps with the QA, but it's not entirely a QA process. So that's kind of general overview of the chaos engineering. So let's get into the example. So I have in my GCP, I have an app which is called Online Boutique. It's a set of microservices provided by Google. It's an open source thing. You can find it on GitHub. Practically, it deploys some sort of an online shop where you can list the products, see the ads, buy something, and things like that. On top of that, it also deploys something that is called load generator. It's an instance of Locust. It's a load testing tool that kind of simulates the user activity. So there something in the background always performs orders, like going through the products, adding stuff to cart, and doesn't buy anything, and things like that. So this set of microservices, it also connects to Google Cloud Monitoring Suite, and they expose traces, they provide comprehensive logs, and for example, to represent the steady state of my product, I created a dashboard and put on a widget that says how many orders per minute I get within a certain time frame. So typically, let's say that I'm good if my shop performs like 20-ish orders per minute. This is typically like per 15 minutes. So this is something that my 21 orders per 15 minutes. This is something that my locust instance in the background can generate. So you can see that there are some gaps, and I'm going to explain what they are. But this whole thing is deployed to Kubernetes. It's so it's an autopilot cluster. The differentiator of the autopilot versus like any other cluster is that you do not manage nodes under the hood. Like there are obviously nodes, but they are Google managed, and you don't even see them. It's something that Google spins up for you whenever you are trying to deploy something. So it has a bunch of things. Bunch of microservices, and that's how the UI looks like, right? So I can browse products, I can add stuff to cart, I can go back and forth, I can place an order, and this particular order, I see this in the logs, and we'll look at this in a minute. So in addition to that, in the same cluster, I have deployed a thing called Litmus Chaos. It's a pretty straightforward setup. They provide you with a single YAML file to set up things or a Helm chart, so you have some flexibility with it, and you can deploy it in a central place and connect multiple clusters to it, or you can deploy it to your targeted cluster. You also get a dashboard that you can look at and where you can run the experiments. Also, to be high, like by default, everyone deploys like either one replica or they deploy like two replicas of the application. When I'm thinking about high availability, I'm thinking about 3+. The reason why 3+ is so you can actually do upgrades and be highly available at that time, like at the same time. So instead of when you update things one by one, you have at least two running all the time that are highly available. So let's see. This is, yeah, and what are the experiments that we're going to perform today? The first one is going to be the disruption of a data storage. And for the data storage for this particular set of microservices, there is Redis. And by default, it comes with the Redis kind of deployed to Kubernetes, which is not the ideal thing. You can connect it to a memory store. So I have here a memory store which is highly available. It provides you with the primary writer and the read replica. As a configuration, I provide two. Let's see. So it's card surveys. Not exactly here. Oh, yeah, here it is. So to enable this cluster mode for Redis, I supply like not a single endpoint, but two. So it will have some the client on the backend will have something to fail over to. You can do this there is no custom development involved, so it's something that you can do and play with yourself. Okay, so the first experiment, yes, as I said, will be the disruption of a Redis cluster. And this is where the implementation through Bash or Python comes in handy. In order to perform chaos engineering, you do not actually need to install anything additional. Typically, cloud providers provide you with a mechanism to do things already out of the box. And if you're in Kubernetes, you have access to kubectl, and you can do whatever you want there too. Google provides a nice command to actually simulate to perform a failover with the data loss. The reason why we want to perform failover with the data loss is because what happens in the real world when such thing occurs. And it's valid for both like Redis, Postgres, and things like that. For example, with AWS, you can easily, because of the way load balancing is structured there, for example, you can force load balancer to be placed like in specific availability zones, and you can remove a load balancer from an availability zone that you're going to fail. So things like that are available for you, and you can do them through API. And the beauty of this thing is that it can easily be a part of the pipeline, right? It's not some sort of an external tool that you have to configure, that you have to connect to, that you have to develop some things on top. It's an API to cloud or to your hosted system. So it's something that really is available for you out of the box. So let's I have my thing going on there. Locust is running. We have we don't have much. Let's see. So and let's jump to now. Okay, so we don't have much going on. Something happened like 30 minutes ago. This is when I tested it the first time. But so far, no other errors. The way I query this, to simplify life a bit, to all the deployments of this set of microservices, I added a label chaos yes. So I can query all the logs by this label, plus anything that either a warning or an error. That's what I'm looking for. And also, it throws a lot of trace to rewrite to write stuff to a local file system, and we obviously have read-only. So I also filter out the noise in our case. So let's see. I run the command. It starts to actually perform a failover, and we will be able to see it in a minute in both memory store dashboard as well as in the logs. Because what this particular log means, and we're actually going to see the same thing. It can it was previously connected to Redis, and now because we failed over, it went to read-only replica at that time, and it cannot write there, which is an obvious thing. So it takes time for Redis, and the same thing happens with Postgres and with any other database. It takes time for it to actually switch masters, so you can perform writes again. So this means whenever such a thing occurs, you lose some data. And depending on your application, it can be something you can restore or something that you cannot. For example, here we cannot restore it because the user tries to order something and suddenly they see an error. Let's see. Yeah, so we've got the same error. So the user tried to actually go to a cart, like and not go to a cart, but add something to a cart, and the user failed because it failed. Like it switched to read only, to read replica because it was available. However, our like memory store in the backend was not able like to keep up with that and get the switch the master. This is something that you would typically see, and this is something that not everyone is accounts for. And for example, not so long ago, I faced a situation when a client was kind of late with the upgrade of Postgres, and the cloud did it for them. So they now they have to dig down and find out the consequences of what what was the cost for them of such an event, and there is highly likely the lost data. So it's one type of scenarios. It's very easy to replicate. It's, as you saw, it's a one-line command. It's something that you can do you can do straight away in your cloud, and you will see how your application reacts to that. Because I saw in the past when there was a highly available database, but the backend connected to the database just as a single instance, not in a cluster mode. So it wasn't it didn't really matter that the database was highly available. The backend wasn't connecting to it in the cluster mode. So things like that is something that you can find out with such a test, a very simple test as you saw. And yeah, you can see you can see right away what's going on with your application. And after we perform the failover, you see that no more errors. So things are going well. So now let's go to the memory store. And in the memory store, we should be able to see the same thing. We should be able to see that we lost few things. Yeah. So we see that. Okay, yeah. So we see that we got a new instance here, plus we see these disruptions exactly at the time when I executed the experiment. So things like that, and that's kind of when the observability in general comes in place. And I'd like to think about observability from several layers point of view. The first one being purely infrastructure observability, and this just gives you a nice picture for what's the CPU usage, right? What's the networking usage and things like that. The next level is logs, APM data, traces, something that provides us with with a bit better view of what's going on. And the third level, something that I'd like to think about in terms of the business metrics. Let's say my business metric is that I should have 20 orders in 15 minutes. So far we're good here, and like the disruption of the Redis cluster didn't really impact it. However, we saw like a bunch of errors, and this allowed us to see that even though we connected in a cluster mode, if something is going to happen in the cluster, there is really not much we would do about like retrying things and maybe saving something in a queue so the payment can be so the item can be posted to a cart later, and things like that are actually good action items to take care of as the result of such an experiment. Okay, so this is one type. Like another type is using Litmus chaos, and this experiment takes more time. You can also perform the same thing with the CLI, but yeah, just to use something different, we'll try this one. Litmus chaos operates with agents, so we have an agent installed in the same cluster where the Litmus chaos is deployed to. So we select this one. We clone the existing scenario. This is this is the delete of the pod, or you can actually take it from the default Litmus chaos hub. Let's add the experiment, and you can search through them. There are a bunch of industry standard experiments across like multiple clouds and generic for Kubernetes. For example, one of the really good things I suggest you all to try is to restart Kubernetes nodes. We cannot do it with the autopilot cluster because of the policy restrictions. If I try to do things like let me get the actual the nodes here. Let's do kubectl get nodes, and if I try to if I take, let's say, this particular node and I do kubectl delete, because it's an autopilot cluster, there is a policy that prevents me from actually doing the node operation level actions. So, however, not all the clusters are running on autopilot. So this is where the disruption of nodes can really in place, and you can target nodes based on labels. So this means you can target nodes based on the availability zone. We will try to do the same with pods. So let's do pod, and we will get pod delete experiment. Now here we have to specify the label. So I have the chaos yes label, which is kind of applicable only to the workloads related to this online boutique application. This is how it will find the pods to kill. And now we need to supply it with something to validate the state. I'm thinking about a good example can be something like, let's try to go and see the product, right? We see that the typical the response is 200, less than 200 milliseconds. So let's be a bit conservative, and let's do 300 milliseconds timeout. And I will actually mark this experiment as failed if I'm during the experiment, I will get like more than a 300 milliseconds timeout on our front end. And what we're going to do, we're going to actually like kill half a specific availability zone. We're just going to kill all the pods there. And let's do this every 2 seconds. And we're looking for 200 response code. Right. So we will run it in a minute, and we'll do it with some force, and will affect 100% of the pods. One thing that like it's kind of for this particular set of experiments, pod-related experiments, you can say like how many pods, like in form of percentage, how many pods you'd like to affect in a single run, like in one time. So with the like within 60 seconds, like every 10 seconds, it's going to run the like it's going to kill the pods, and it's going to kill the 100% of the pods 6 times practically, or 5 more. Yeah, then I think that's it for configuration. Now let's look at in form of a YAML, which is a bit easier to digest as far as I can tell. And let's look at it here with a bit better UI. So it's a custom Kubernetes resource. So it will spin up a job, a Kubernetes job that will actually perform the experiment under the hood. So we will, let's see what we're looking for. Here is the configuration, right? It's a default configuration. And one thing that we're like, what we can do here, which was not in the UI, we can target specific pods by name, which is kind of something that you might want to do, but it's not our case. What we want to do is we want to target a node, like, but not might be a single node, but multiple nodes. And the way we can do it is by labels. So let's try to let's try to get the, say I have the US Central 1F, which is one of the availability zones we're running in. Let's try to get the pods in this availability zone, and that's what this command does. It's getting the nodes based on the specific label, gets the name, gets the list, gets it in the form of a list, and queries all the pods, and passes the name, and passes the node name that we get as a variable here. So we will if we run it, we actually get the following list of pods that are running in this particular availability zone. It appears to be that they are all in the same node, which is just due to the fact that it's a small application. But there are quite a few very interesting things, as you can see. We have multiple services, and for the card service and for recommendation service, 2 replicas of it running in the same node. So it's a good reminder for every one of us. Even though we set the 3 replicas in the like number of pods, there is not much guarantee that they will be spread evenly across the infrastructure. And this is something you can do if you set node affinity, and you can actually tell the pod, you can supply a deployment configuration with a selector for a node. So it's something that typically is a best practice to do, because you want to spread your workloads evenly throughout the availability zones. So if you're running in 3 availability zones and you have 3 pods running, you want every single pod to be in a different availability zone. And this is something you can achieve through this node affinity configuration in your cluster, in your deployment definition. So again, like if you say replicas 3, there is literally no guarantee that it will happen. It might happen. Kubernetes is a smart thing. However, as you can see, we can have like 2/3 of the workloads for a particular service running on the same node. Okay, so it's what we need to do now. We need to actually get the label, and it's this particular one. It's topology GKE IO zone. It's a standard label for GKE. There is the same label for like exists for AWS, and the same for like kind of similar for Azure. So it's pretty configurable. And what we want to do is to add it to our let's see, add it here in the node topology. So it's not something that you can override through the UI. It's something that you will have to affect the YAML directly with. And you can run multiple within this same configuration. You can run multiple experiments. We'll just concentrate on one today, but it's just you can run as many things as you want. And here we just double check that here we override our the total duration. Why is 30 seconds? Let's do 60. Like every 10 seconds, we force the deletion, and we can affect 100% of the pods. Okay, let me just double check one thing. I probably didn't paste it correctly here. Yeah. Let's check again. Node label. Node label will be this. And yeah, we paste it here. And here in the overrides, we have 60 seconds as a certain as a duration for the experiment. And we force the execution, and we affect 100% of the pods. Plus, we always have the probe running in the background that will help chaos, Litmus chaos to verify that everything is all right. So let's get this back. Save the changes. We then schedule the experiment. We can actually do this, we can do some simple cron, right? We can run it every hour, every day, every week, or every month. Very handy if you, let's say, want to fail a specific random availability zone every month as just a part of a drill. This is a very handy configuration. So we'll run it just now, and yeah. Finish. And now what we have, we just have to observe. So let's see then what happens. If everything goes as planned, which is might not be the case because of the Kubernetes, but if everything goes as planned, we will have these pods deleted, and we will see. Let me get the logs. And we will see this particular error, which is kind of it's for the recommendation surveys. Let me configure the time a bit better. Okay, yeah, we will see there like this. Because we have a bunch of we have 2 replicas of the recommendation service deployed. If we delete them, the way these microservices are developed, we will not be able to retrieve the products, the recommended products through the website, and we can actually see it. We can see it here. So this is the this is the section with the recommended products. It's loaded not through the front end, but it's loaded on the back end, and then it performs server-side rendering. So it will not be able to do it, and our probe will fail, and thus the experiment will be failed. So this means, even though we are kind of highly available, we have 3 replicas up and running of all the things. If we shut down half of the, if we shut down the one availability zone that doesn't really have all the services in it, but it has several services in it, a user for a short period of time will not be able to open a page without an error, and it will take them more than a second to do. This is something that kind of you can replicate yourself and see, but let's. This experiment takes it takes a while to run. Typically, it's 7-ish minutes. I hope we will not see any errors. Okay, so it installed the experiment success. Now I think it will be able to run the things. Let's continue to monitor what's going on here. So Kubernetes will place these particular pods in another availability zone in another instance. So we'll in a few minutes we'll not see much here. And this is one of the experiments that we successfully performed in the past. It was not so our client had the ecosystem of multiple applications running, and what we were trying to find out is whether there are any single points of failure, and whether the user flow will be disrupted if the availability zone fails. So we kind of killed the the availability zone, just one of them, and we were lucky enough to can trigger a couple of things. First one is the NAT gateway for the internet, for the communication to the internet, was placed just in a single availability zone, and this kind of prevented all the communication outside of the network for the time of the experiment, and communication with the external system and data providers it was lost. So it was something that we found out as the result of that experiment to actually that actually helped us to make the product more resilient. And as you can see that I tried to get the pods again, and now we have and we have less because things got deleted. It replaced the same it replaced a couple pods here on the same node, but it's not a big deal. So for 30-ish seconds, there were a bunch of resources that were not available. And let's see on our monitoring whether we see any errors. Right? We actually are, which is kind of tricky. So local standard hood was trying to simulate a user that was getting into the product page, and that particular user was not able to do that. And it's a front end, it's a front end application, right? It's an app, it's a front end app. We had only one instance of the front end app in this particular availability zone. However, because we had like recommendation surveys deployed here, and 2/3 of its capacity, we kind of failed the UI, and it's a very short-lived thing, right? Because due to the nature of the experiment and the self-healing capability of Kubernetes. But if you're running on the VMs, if you're running on Kubernetes on VMs, and you do not use autopilot or Fargate, these are the things that you you can definitely face. And these are the things that impact the reliability of the product that you can check only by simulating it. So it's not something that you typically account for. Okay, let's see. Yeah, and now our experiment is marked as failed because let's see, because we got the failed probe. And as you might recall, our probe configuration is every 2 seconds we send the request to this page. We expect 200 response code, and we can fail if it takes more than 300 milliseconds to load, which was pretty reasonable because our try showed that we can actually expect 150 milliseconds typical load time. So it's twice that time. And this is something that can show us the weaknesses of our application. So what can we do with that, right? You can obviously put these things into the pipeline and run it every week or every 3 weeks, do this drill. But the lessons learned out of that are that applications have to be developed with the resiliency in mind. And the reason why I'm saying that is because we kind of performed just 2 very simple infrastructure level experiments. We failed, we did a failover of a Redis cluster, and we deleted all the pods in a specific availability zone. This showed us that our application, if something happens to the Redis cluster, cannot actually add product to the carts, and it can prevent our customers from buying actually stuff from us. Because it was a simulation, we had quite a quick recovery, but it's not something that happens all the time. So one outcome of that we could take is that we have to implement some sort of a retry mechanism, and we should be able to do the fail safe type of thing that would, instead of writing this on the back end, write this in the cart on the front end in the storage, and later on sync with the back end when it becomes available. things like that. And with the pods, with the deletion of the pods, one thing that we could take out of this experiment and implement and put in the backlog is, despite the fact that we have three replicas set for deployments, we actually ended up in a situation where we have two replicas of a service, and even like it's the case for two services running on the same node in the same availability zone. So the action item for that will be to add the pod affinity that will force Kubernetes to spread it evenly across the availability zones. And these things will help us to make the product more resilient. And I think that's pretty much about it. So I'm looking forward to the questions.
All right. Yeah. So if you have any questions for Alex, please do put them in the Q&A chat. It's a separate tab. So if you see the regular chat, it says general Q&A and DMs. You can click on that and just type it in there. I do have some questions for Alex as you're kind of thinking through yours or typing yours. Yeah, so the two scenarios that we walked through, Redis cache that was set up with a primary and failover, and then we had one where we just killed one availability zone worth of our application. So in both of those, yeah, you'd think that the architects of the system are thinking that they have done a good job of designing their application. With chaos engineering, meaning you intentionally pulling down parts of the system, to show that there are failures. Are these? And I think I was picking up on this as you're talking, that these are things that you've seen at your customer sites, and have you used the chaos engineering with your customers to kind of help them strengthen their design?
Yeah. So these kind of availability zone level failure experiments, it's certainly something that we've seen like happen in the past, and it happened like not once. So it happened like several times in the past couple of years.
Mm-hmm.
And it's something that, like, when I'm talking about chaos engineering, this is something I'd like to start with, because it's the easiest thing possible to implement.
Yeah,
it's just like either you are multi-AZ or you are not. There is nothing in between, and you just shut down the half of the availability zone. In some clouds, it's easier to do. In others, it's like not as straightforward. For example, like with GCP, especially with autopilot, it can abstract a bunch of things for you. So we have to do these tweaks to query the to kill pods based on the node label they're running in and things like that, instead of just like shutting down the nodes. And so the availability zone failure level experiments, it's something that I see the most.
Mm-hmm.
Then the data storages failure,
Yep.
meaning like the typical scenario is whether like you're running, let's say, Postgres or like memory store in our case, right? You must specify maintenance window. It's something that like it's a required setting. And during that maintenance window, cloud leaves the right to actually perform the upgrades.
Okay.
And this means they will shut things down. They will run, like they will switch the masters. They will like do the failover.
Mm-hmm.
But as we saw, it depends on how you write the code. It depends on how you handle these scenarios on the code. On the infrastructure side of things, they do what they can to minimize the time it takes like to switch master from one node to another, but it still takes time. And even with the basic load test, it's it's not running like crazy number of users. It's just constantly like doing an order approximately every 20 to 30 seconds.
Yep.
So it's kind of might be like 20, 30 requests or 50 requests per minute. So not much. And still we were able to catch it, and we were able to catch one error for this. And then like if the when the traffic grows, this thing just compounds and and multiplies. Another thing that I saw is the cloud service specific set of errors. Typically, like API is unreachable, or if we if we talk about AWS and there is SDK implements retry mechanism.
Okay.
So something like if you're calling a DynamoDB table, you add the latency to DynamoDB to trigger a retry on the client side. And still it does it means that it will get the data, but it will get data later. And we saw scenarios with eventual consistency where you expect you put the data there, but due to this latency thing, you do not actually get it in the subsequent API calls. So things like that are kind of the top three failures I would tell you I see. The cloud API level, availability zone level, and the storage failover.
Okay. Yes. Got a couple questions that have come in. One from Randall Lee. I'll ask it, and then I'll ask a quick follow-up, and you can handle those together. So, just in the demo, looks pretty easy. You just kill some stuff. But do you, with your customers and maybe on your own things at DataArt, do you do the chaos engineering in production? That's the question. And then if you do it in production, what kind of preparation do you do, not necessarily technologically, but maybe on the people side to get ready for running those types of experiments?
Yeah. So let me just quickly get back to this, right? So running this in production is sort of like the end goal, right? It's kind of the ideal state. Doesn't mean you have to get there, right? So it's just a certain maturity level. Many customers, many people, people in general, are not comfortable enough to run this in production. The reason why they are not comfortable is because they do not believe in the reliability of their product, right? This is why you have to go through that journey. You have to define the steady state. You must have the observability in place. You must do this manually first in your development environment. Then you must do this in the you must automate this. Then once everything is settled, you do this in the staging or pre-production environment, and you move out through the SDLC. It's practically like a feature of your system. You can even say, right? It follows the same SDLC, and eventually you you can run it in production. However, I've seen very few people get there. The industry, in the chaos engineering as a practice, is not yet mature enough to do it at this at scale.
Okay. Yeah. So the goal is, yes, it would be great to be able to do it in production, but don't just go and do it there. Build up your skills and your belief in your system by practicing in lower environments, and then only then try it in production.
Yeah, typically, you can think about it that you can go through this crawl and walk part with defining state, doing observability, and developing the experiment in the development environment and automating it at some sort, within 3 months time frame.
Okay.
And this kind of gives you enough confidence to proceed and do this in the bit higher environments. And then it just depends on what's your appetite for the and what's your confidence right now in your application.
Right.
Certainly don't go right now and delete stuff in production. If you do this, I tell you, do not do this. Yeah.
All right. A question from Sam Nichols. We're looking at a Kubernetes example here. He's wondering about maybe there's applications that are more just on virtual machines and load balancers. Have you used chaos engineering in VM based application scenarios as well?
Certainly, it's not only can be applicable to the VM based workloads, but also to serverless and cloud native stuff in general, right? What I showed today is just on how you can use the tools. But these are tools, right? There are other out there. Yeah. And what you can, for example, do with relation to serverless workloads, because they are scalable by themselves, right? Yep. Things like that. You can do the experiments on the code level. And if you're running Node or if you're running Java or whatever, you can do the you can inject these experiments in your code and trigger them based on a certain configuration or environment variable and things like that will purposefully slow things down or return incorrect responses or stop the requests and things like that. And with regards to VMs, again, Kubernetes is just a setting on a very fancy setting on top of VMs that allows you to orchestrate containers. Still under the hood, you have the VMs. So one thing that was particular with Autopilot, you do not control VMs. Yep. I showed the example when I tried to delete a node, and it didn't let me do this. So you can delete a node, meaning you can delete a VM if you have one, of course.
Yep. All right. One more question from Rajesh Kumar. He's thinking about chaos engineering. They're doing the experiments, and maybe a chaos that has gone out of control. Do you have experience with how do you control the experiment so you don't accidentally take down too much? And have you found yourself in any scenarios where the chaos experiment just kind of did more than expected or whatever, or did too much damage? Any thoughts on that?
Yeah, sure. So I actually had such a case when we shut down the availability zone, and it triggered a chain reaction that that helped us to identify a couple things, such as that we used a single NAT gateway instead of highly available NAT gateway, and that some of our systems were designed to be they were migrated from the on-premises, but they were not designed to be highly available.
Right.
And obviously they were down, but what we didn't account for is that they played the crucial role in the user flow. And this actually stopped the user from proceeding through the flow because the services were not available. Typically, if you read about the chaos engineering, they say you to start small. They say you to do the smallest possible blast radius.
Yep.
But I would probably challenge that because you don't do it straight in production.
Right.
And the whole purpose of the exercise is to find out what happens if such an event occurs. Right? It prepares you for a disaster. It allows you to check whether your runbooks are in place, whether like you have the whole procedure in place, or whether you can even tell that something went wrong, which like not always the case, right? And that's why like I don't really believe in the overkill in the lower environments. If you like, if by failing, let's say, in availability zone, or like just failing, or by failing over a database, you can like put in some corrupt data, or your application exits with a code 1 and just stops working. It's a good thing that you found it out in the lower environment.
Yep. So that's some good advice, which might be a little different, that like you said, that you'll find in books, is start small and move. But since we're not just doing it straight in production, you want to try an experiment that's a kind of big one, maybe failing over the database or taking out a full availability zone. See all the things that happen. Now you have a lot of data coming back. Maybe you have things to fix, or maybe things work good, but it gives you a lot of feedback, and it's in a lower environment. So if you takes down an entire user journey, breaks a workflow, it's not a big deal.
Yeah, and I would also add to that because like typically, again, based on the general like industry practice, you start small, and like you can see in many demos, in many examples, that like a very popular experiment that you apply is like you add the latency to a request, or you like let's say shut down a surveys, which is a valid experiment for sure. But the value of the chaos engineering, in my opinion, is when you apply it like on a bit bigger level. Right. This is a very small blast radius that shows the value on a very small level. But if you, let's say, do an experiment like such as shutting down the availability zone, or just like or just stopping the traffic in the availability zone, so nothing can like call anything like outside of that particular availability zone,
right?
Which is a networking way of shutting down the availability zone.
Yep.
This is a real-world scenario, right? It's something that happens like not only with in the abstract world in the lab. It's something that happens in the real world.
Right.
So I would encourage to to look at the past incidents and use them as a base for your chaos engineering journey.
Oh, cool. All right, one final question. This one's from me. I like to ask every speaker this one. It's not a technical one. It's a kind of a career type of a question, maybe to help anybody out there that's at the beginning of their career, or looking for some advice. So this would be you, if you could go back in time and talk to your 20-year-old self. Is there, now as a more experienced person, is there some advice that you would give your younger self as far as career growth, or what to do?
Yeah, that's a good question. So, like, I started as a software engineer back in the days, and one thing that I would probably do a bit differently is, in addition to starting as a software engineer, I would look into cloud straight away. This kind of because this whole DevOps world and the cloud world is a very broad thing. You cannot there are very few people who understand everything. And because there is just so much information and so much things to know about and to learn, in addition, like to software development, which is on its own like exists for many years, and it's a huge field. Still, cloud plays an essential role, and it's something that I would start with earlier. And yeah, just the way I would approach it is probably would do a bunch of POCs. You can read documentation, you can watch videos.
Yep.
Unless you actually try to apply it, there is no way for you to learn.
No, great. Yeah, so you tell yourself, software engineer, still a good path. Add on the cloud skills, and not just from an academic point of view, from reading it. Go get your hands on, get your hands dirty, where you can really learn, what is going on, and kind of continue to build that skill stack, so you can, be a good software developer, no infrastructure, and be able to add value across the entire stream.
That's right. It would be cool if you are not only writing a code, but you also know how to write serverless code, for example.
Yeah.
And like you do not put the whole framework in a single cloud function, and you split things out, you keep it small and things like that. So the earlier, because there's just way too much information to know right from the start, the earlier you start, the better. However, it's better to start than not to start at all. So don't be afraid to start even if you missed it.
All right. So Alex, definitely appreciate the time that it took to come tonight and to prepare the presentation and the demo, and to answer our questions. So thank you very much.